You're welcome. Copy the diagram and copy your sketch. On your copy, sketch the graph of y equals. So we talked about this yesterday. Who can remind us how do we sketch a graph of the inverse?
You flip the
So be a little more specific.
like your x goes to where your y is, your y goes to where your x is.
That was not any more specific. That was just doing it in a different way.
I don't what.
So what do you have to do before you can switch the x and y, Deborah?
Cry a little bit.
No, you don't cry a little bit. There's lots of crying in math, but now is not the time. You do a
Maybe
T-chart.
not for you.
T-chart. I told you this. T-chart, T-chart, T-chart. Get a set of points. Do them for the line and do them for the curve, which is a parabola-esque thing. But get points, especially that point of intersection right there where those two are at the same place. Get that point, and then do a T-chart and X and Y values. So make sure you do that. Remember also, it reflects across the line y equals x. That should go directly through the middle, things like that. Um, okay, so you should be able to, I mean, they gave you a picture of what the graph looks like, so yours should look something like that. But again, the easiest way to sketch a curve or sketch f inverse is find your x's and y's and then switch them, especially when they give you a function. If they don't give you a function, for instance, you draw the line y equals x as best you can, and then just reflect it across that. So that's the easiest way of doing it, or really the best and only way of doing it.
What was going to be my next suggestion?
Okay. And then C, obtain expressions to define the function f inverse, giving also the set of values for each expression. Okay, that I will need to work. Okay, so it's 3x minus 2, 4 over 5 minus x. What was this one? The domain negative 1 to 1, both equal 1 to 4. Okay, so the first thing is find your inverse functions. So very easily, you get that y is equal to 3x minus 2, and y is equal to 4 over 5 minus x. So the first one's easy. You get x is equal to 3y minus 2, x plus 2 over 3 is equal to f inverse. Here you get x is equal to 4 over So solve for your two inverses, which should not be tremendously difficult. So we got to write your f inverse. We do our piecewise, and we have one part of it is x plus 2 over 3, and one is 5 minus 4 over x. The question is, what are my x values going to be on my inverse function?
The y values of your original function.
Very good, Miss Kayla. So we have to figure out what those are. So you plug in your endpoints to your original. So in this case, we're going to plug in negative 1. So it's negative 5 is less than or equal to y is less than or equal to 1. And then when I plug them into this one, I get, if I plug in 1, I get 4/5. Or no, if I plug in 1, I get 1. Going crazy. And if I plug in 4, I get 4. So 1 is less than, y is less than or equal to 4. Okay, so these are your ranges from this one. Yeah. So they're going to be your domains down here. So pretty straightforward. So -5 is less than x less than or equal to 1, and 1 is less than x is less than or equal to 4. Hey, I got it right. Good job. Questions on what I did there?
Yeah, how did you find the thing? The -5 was less than x, which is less than 1.
Do you
I know you just explained it, but I wasn't listening because I was trying to do the other thing.
That's fine. See how I got the y's above it at the top right?
Yeah.
Do you know where those come from? That makes sense?
Well, because it's the other, like, flipped. Yes, it makes sense.
Okay, well, because we are an inverse, we are switching those, so that range becomes the domain of the inverse.
Okay.
So anytime they're asking you to find the domain or the set of x values or whatever, if you can find the y values for the original function, which is usually pretty easy, that gives you your domain for your inverse, or vice versa. If they're asking for the range of the inverse and you know the domain of the original, then that has to hold true.
Mm-hmm.
So they're really asking the question, do you understand the domain and range, and the fact that they switch from function to inverse.
Okay.
Okay. 8. I am not doing A. We've done enough completing the square that everybody should be fine with completing the square at this point. And you can find the vertex, coordinates of the vertex, either from that form that you just found, or you can take the derivative and find it. That's something that I believe everybody in here can do. Make sure you practice it, though. Don't take it for granted. All right. And then B is the range. So how do we find the range of in this case, a quadratic function? Somebody explain that to us or tell us how to do that. Somebody, anybody, how do you find the range of a quadratic
Find the
function?
vertex and see if it's concave up or concave down.
Okay, so yeah, pretty much. So in looking at this parabola, it should be really easy to tell, does this parabola concave up or is this parabola concave down?
Up,
Why up, Miguel?
because the x squared is positive.
Correct, so it's concave up, so what does that tell you about your parabola value as far as the range goes? Or sorry, your vertex value, not your parabola value. Your vertex value as far as the range goes.
Oh, 11.
Did you just say 11? What does the vertex tell you about the range of the parabola if it's concave up? And the answer is 11.
Will the vertex be above the x-axis or no?
That doesn't
It's the
matter.
minimum point.
There you go. Thank you, Miss
Oh,
Alyssa.
okay.
So what does that tell you about the range if the vertex value gives you your minimum point?
Then your max is infinite? I don't know.
That would be correct, yeah. So your range starts at your vertex value and goes to infinity. So you find your vertex from part A because you already have that. Again, I'm not doing the whole problem, so it's not that important. Um, so you find your vertex from part A, then you figure out that, oh, it opens up. So therefore, my range is from that value of my vertex to infinity. Part C, for anybody who actually worked part C, do I need to find the inverse for you? Should be pretty straightforward, I think. Okay. So how do I find the domain of G inverse?
It was the range.
It's just the range of the original function.
So correct, it is the range of g, which you've already found in part B. So your answer to part B will be your answer to part C, because they're asking you basically, do you understand that the domain of G inverse is the range of G? So very good. Okay. Now you do have to be careful. I will caution you on C. If you have not worked C already, make sure you work it and get the correct inverse. You have to be careful on your plus or minus when you're doing square roots with these, so make sure you work that if you have not already worked it. But you will have to be very careful on that one. That one uses the negative version. I'll give you a hint. Okay, number 9. More complete the squared. Okay, no problem. Alright, part B. What do we know about quadratic functions if we need them to be one-to-one functions?
Then both the regular function and the inverse function have to be functions.
Which means what?
They need to pass, or the original function needs to pass the horizontal line test.
Very good. And now specifically with our quadratic functions, what does that mean we need to do? We have to do something to that quadratic function, because obviously a parabola does not pass a horizontal line
You
test.
need to restrict this domain.
And where do we restrict said domain?
At the vertex.
At the vertex. So this question very easily is asking you, basically, hey, restrict its domain at the vertex. They're just not telling you that. They're expecting you to remember and understand that. If you need to make a quadratic a one-to-one function, you restrict it at its vertex. Now, could you restrict it other places? Yes. But when you're talking about the smallest possible value of k, that's always going to be its vertex. Because obviously you could cut it after the vertex and it would be also a one-to-one function, but they want to know the smallest value. And that is going to happen at the vertex value, which you found in part A. Okay, part C is really easy. They give you your k value. And then part F. Okay. What is that? I don't like this answer. How did they get 27 for the domain? Okay, I'm not gonna lie, I don't know how they got 27 for the domain without doing the problem. Because the range of f is not... Oh, it's a continuation from C. That's a pain. Okay, that makes more sense now. I think they needed to redo the numbers. They numbered it, they did it incorrectly. So C should have been moved down. Okay, so not too bad. Do I need to find the inverse for anybody? Like, legitimately answer yes if you need me to find the inverse for you.
Can you do it real quick?
I can. That's why I asked. So the first thing is you have to have done A correctly in order to be able to find the inverse, because you're not going to be, remember I gave you the hint, you're going to not be able to do the inverse if it has like 2 x's or 2 y's and things like that. So you will need to do it from the factored form. So for part A, your answer should have been to, I think it was -5. Yeah, so that is your part from A, which you will need to find the inverse. So y is equal to 2. So switch x and y. Minus 3 squared. So x plus 5 over 2. So square root. So you get that equation there, but the question is, always ask yourself, do I need plus or minus in front of my radical? If we look at the answer to part C, the range is, so we know for this function, we know x is greater than or equal to 7, and y is greater than or equal to 27. So in our inverse, we need that x is greater than or equal to 27, and y is greater than or equal to 7. So the x part, no big deal for the domain, that's pretty good. Get that, not a big deal. But the y is greater than or equal to 7. That's where you got to be careful. So since you're doing that, that means y needs to be positive, which means I need my positive version. So I can get rid of the plus or minus because I only need the positive version, so you never put a plus in front of it unless it's being attached with other things. So always be careful to check the plus or minus part. Good, Alyssa?
Yeah.
Okay. Number
How do you
10.
find P and Q?
The hell are P and Q?
Look, the C.
You're on the wrong question, sweetie. We just finished 9. I'm getting to that one now. Okay, so number 10. Again, I'm not going to complete the square. I've done it hundreds of times by now, hopefully. Part B, though, the function f is defined by p, q, or p positive. The range is given by c and d, where c find the smallest value of c. Okay, so x minus 1 squared minus 16. So this one has a little bit more going on to it, so we'll do it. Okay, so if you do part A, or when you do part A, or having already done part A, hopefully, so you get that it factors to x minus 1 squared minus 16. So what is this the graph of?
Parabola.
It's a parabola. What kind of parabola do we have?
Concave up.
So it faces up. It wants to know the smallest possible value of c. Well, c is for the range, so what is the smallest possible y value, in other words? Well, if this is a parabola that opens up, where do we obtain the smallest y value?
The vertex.
And what is the y value of my vertex?
Negative 15.
How?
Negative 16.
Thank you. Don't know how you got 15, but okay. So your vertex, smallest value of the range C will be negative 16. So that's the answer to part B. Okay, and then for part C, they tell us the range is from 9 to 65. Is it equal to's? Yeah, they're equal to's. Okay, and they want us to find P and Q. So in other words, so we now know C is gone. Backwards. So they gave you the top line where C and D are 9 and 65, and they're wanting you to find P and Q. So what are the ideas on finding P and Q? Anybody have any ideas on how to find P and Q?
To be honest with you, Chief, no.
What are P and Q?
Constant?
Constants. Positive constants at that.
I mean, they are numbers, is what your constants, yes, but what are P and Q? What do they represent?
The domain.
X values.
Both of those answers are 100% acceptable. They're your domain or your X values. They have told you your range is from 9 to 65, and they've told you you're looking for the domain. You could definitely draw a sketch of this graph at 1, negative 16, does something along those lines. So always have in your back of your head, or even on the paper, if you really need to, draw the graph if they're asking you questions about them.
Is like domain and like stuff like that, are those the same thing as bounds, or am I like going?
You could say bounds, yeah, that's fine. But when we talk about specifically the domain and range, we call them a domain. Some people would say the bounds of the function and things like that, but it's better to be more specific than just to say the domain and range versus bounds. But yes, that would be fine. Okay, so if you look at your function, you're basically looking for your 9 and your 65, and we're told, like I said, find P and Q. So basically, it's a relatively. Ooh, there should be 2 answers actually, I think. Because let's see, that's negative 16. So yeah, so there should be 2 answers if I'm not mistaken. Let me make sure that they give 2 answers unless there's something. Oh no, but it tells us that P and Q are positive constants. Got to be careful. So P and Q are positive, so I only need the positive side. So I don't need any of this side of my graph over there. So I look and find where it's 9, 65, which will be like there, and there. So that'll be P, and that'll be Q. So you're looking for your X values that give you a Y value of 9 and 65. That's basically all you're doing. So when we have that, just plug your Y value in and solve for X. So 9 equals X minus 1 squared minus 16. So that's 25 is equal to X minus 1 squared. X minus 1 equals 5. I need the positive values because I'm only doing positive values, so that's fine. So X equals 6. So P is 6. And then do the same thing, but do it with, what, 65? So you get 65 is equal to X minus 1 squared minus 16. Is that 81? Yeah. So 81 is equal to X minus 1 squared. So 9 is equal to X minus 1 plus 1. X is equal to 10. So between 6 and 10. That's fine, Bridget. Go ahead, sweetie. Does that make sense on how I found P and Q? Any questions from anybody?
No.
Okay, and then part D, they want you to find an inverse. Being careful when you take the square root. I believe this one will be a positive version. Yay, I'm correct. So making sure you're taking the positive version of the square root. In this case, always check for positive versus negative. Do I need to find the inverse for anybody, or does everybody feel comfortable doing that? Okay. Number 11. I think this is the exact same thing we've been doing. Is there anything different about it? Ooh, D could be a little fun. Let's see. Yeah, we'll do D. Why not? It's a little different. Alright, so I'm doing 11D, unless anybody needs me to do 11A through C. Speak now or forever hold your peace. Alright, cool. So D, they give us 2x squared minus 12x plus 7. I think I remember that wrong. Thomas, you're making a lot of noise there. 12x plus 7.
Just kidding.
And then g of x is 2x plus k. And we're doing g of f of x. So they made it easy for you. So when they write g f of x like that, again, somebody remind us, what does that mean? Okay, again, when they write g f of x like that, again, someone remind us what they mean.
You're plugging f of x in the g of x.
So they are doing g of f of x. So what you are doing, like Miguel said, is plugging f of x into g of x. But that is your g of f of x. That's your fog and Goff stuff back from algebra 2. So basically plug your f of x into your g of x, which they made it easy for you, not doing it the other way around. So 2 times 2x squared plus k, so we can distribute 24x. And they want to know, so they have said 24x plus 14. If I set it equal to 0, I want 2 equal roots. Find the value of k. What does it mean to have 2 equal roots?
I don't know. Please explain.
Well, that means you have a repeated root. If they're equal, that means you have the same thing twice. So what kind of function do I have here? It's a parabola, so, or quadratic is fine. So a root, you need to remember, if you don't know this, you might want to write it down. Root 0 solution relatively all mean the same thing in this kind of case. So if they want 2 equal roots, that means they want 2 equal solutions. They want 2 zeros to be the same. Well, what that means in our case is a repeated root. You know, if only someone had showed you last week how to find if it's a repeated root. Man, that person would have been really smart. Oh wait, I know somebody like that. Does anybody remember how to tell if it's a repeated root?
A perfect square?
No. I mean, I guess technically, actually that would work. I mean, I can't lie. However, that would be a really difficult way to do it. Anybody else any suggestions to find a repeated root?
Yeah, no.
The discriminant.
Oh,
Taking the
that is a
derivative.
thing.
No derivatives.
Oh,
You will take very few derivatives in ACE Math. There may be like one question usually on an ACE test that involves derivatives. But you got to remember with quadratics and dealing with things, the discriminant, we talked about this last week, greater than 0, less than 0, or equal to 0. If I want a repeated root, the discriminant has to be equal to 0. That is the only way to get that accomplished. So at that point, you just plug in everything. So A is that, B is that. You do need to be careful. C is the 14 plus K. So you get negative 24 squared minus 4 times 4 times 14 plus K equals 0. And that is a relatively straightforward equation to solve. Everybody should be able to do that. I don't know what 24 squared is, though. So. 576. So you get 576 minus 4 times 4 is 16. Whatever 16 times 14 is. Minus 16k equals 0. So we get 16 times 14 is 224. $352. And I get a value of 22. So it's 352. So you get 352 minus 16k equals 0. K is equal to 22. Questions on how I figured any of that out?
I think that's a no.
Yeah, I get a lot of silence. I'm used to it. It's cool. People being AFK, you know. Understandable.
Okay.
You just realize I'm never AFK. I'm always sitting here listening.
You never talk. What are you talking about?
I never talk, but I'm never AFK. I'm always here.
Yeah, I'm never AFK.
Nolan, I guess you don't know what AFK means.
O'Donnell.
Yes, Michael.
I forgot I changed my button to enter for push to talk.
Why would you ever do that? Why would you ever make it enter?
I had it on a different key, but when I pressed that key on for my physics class, it scrolled down the page.
I would suggest Control or Alt for push to talk keys if you have them.
Mine Shift.
Shift also is not bad. Shift works. But yeah, Control, Alt, or Shift are usually the best ones. What'd you say, Valeria?
What does AFK mean?
Away from keyboard?
Oh, you're joking.
It means
No.
you're a non-gamer. That's what it means.
That means you're not at the keyboard, so you're not at your computer, basically.
I didn't even think about that.
Yeah.
Okay.
Basically, it
Of
means
course you
that people
didn't.
log into Discord for class and then leave, and they pretend that they're here.
And then just leave.
And then, you know, like the 4 people I had to kick from Discord yesterday because they weren't here after we ended class, which means they definitely weren't here.
Aha.
Really?
Yes, really.
Yeah, I was sitting here trying to be the last one to leave, and he had to kick 4 people.
Yeah, I pay attention to these things. All right, number 12. F of G and G of F. Do I need to do 12 for anybody who actually did 12? Because it's relatively easy to plug them in. And very nicely,
did
they
it.
ask you for both of them, so it doesn't matter if you know which way to do it. You just need to do both of them. Did you need me to? Did you need me to do either of them for you, Valeria, or are you okay?
I think I'm okay. Can you
Okay.
hear me?
Yes.
Okay, I thought I had pushed the
Push to talk.
Do you want to? Is a different
thing,
question.
and I was like, oh my gosh, can they hear me? Is my button not working?
No, we can hear you.
Yeah,
Sorry.
no, we can hear you.
You're good.
We don't want to, but we can.
Oh, shut up, Will.
That was a good
I
one, Will.
didn't
All right.
say anything.
I stole that from Thomas.
I told him to shut up. Don't worry. All right. Back to number 12. B should be pretty easy. Just set the 2 equations equal and solve for the value of A. So that's a pretty straightforward equation. It's a quadratic, but I mean, you just set 2 quadratics equal to each other. Pretty easy problem, I think. Do I need to do B for anybody who did it? I mean, there's nothing abnormally difficult there, I don't think.
No.
Okay. Find the value of G of B where B is not equal to A, so B can not be whatever value we just found, okay. For which G of B equals B. Ooh. How in the world do we do that?
don't know.
It's actually a lot easier than you think.
It just looks like y equals x.
Something along those lines, yes. So they want to know where g of b equals b. Well, it's actually a lot easier than you think. If you know g of x is equal to x squared minus 2. So g of b is b squared minus 2. Basically just where is b squared minus 2 equal to b. So how do I solve b squared minus 2 equals b?
Wouldn't it just be a quadratic?
I just want to say 2.
2 actually ends up working, but you got to be able to solve it and show the math behind it. So what do you mean by it's a quadratic, Kayla?
Like you move the b from the right hand to the left.
Okay, how do I move it? Be a little more specific.
You subtract.
You pick it up.
just pick it up and move it over. Yeah, you know. B minus 2. So, but yes, that is correct. Good job. So you get two values here, where b is equal to 2 and b is equal to negative 1. However, they have told us in the problem that b is not allowed to equal a, and a was negative 1. So b is equal to 2. And yes, your answer was correct, Will, but you need to show work, remember?
Yeah, I knew I had to show work. I was just looking at it 2.
Yeah, sometimes they're pretty
2
easy
works.
to... They're
I
pretty
said
easy to
2
kind of
works.
figure out, but you got to be careful. Especially with it being a quadratic, it's obviously going to be a lower number, because once you start getting squares, they start getting really big really fast. So there's a couple of hints to figure out kind of lower. It's a lower number. But
1 would not work. 2, yeah. 3, no.
All right. D, find and simplify an expression for f inverse g of x. So you got to be really careful with that. So you need to know what to do in what order. So you remember f inverse of g of x. Just make sure you know what that means. That's where a lot of people kind of make mistakes and things like that. So f inverse g of x means f inverse of g of x. So you plug g of x into your f inverse. So you have to be very careful there not to make mistakes on which functions are the inverses and things like that. So just being very careful. And then E, find an expression for it. That's really easy. Okay, so I don't think I need to do E. That's just an inverse we've done before. 13, we've got two functions. Hey, look at that, another complete the square and a range question. Oh my god, and then the domain of the inverse. Oh my god, it's like they're connected somehow, and they want you guys to realize there's a connection between them. How? Oh god. I hope everybody's written that down by now, because if you don't know that, I'm going to throw something at you.
Yes.
Sketch on the same diagram y equals f of x, y equals g of x, and y equals inverse, making clear the relationship between graphs. There is no relationship between f of x and g of x, so... It's a line and a parabola. I'm very confused. I mean, clearly there's a relationship between the inverse functions, but g of x is just a line. Oh, g of x is the line across which it's reflected, because it's y equals x. Okay, that makes sense. So remember, again, the whole idea here is that when you draw a graph and you go to do your inverse, so once you have your coordinate plane, if you're going to draw an inverse, you will flip it across this line one way or the other. So in case you haven't figured out yet an easy way to do that, you could draw it and then take your paper and flip it over, just as a little reference. So take like an extra piece of paper, sketch the graph, and then flip it over that line. There's a couple different ways you can do that to make sure you get the correct graph, things like that. And as I've already pointed out and mentioned, as we talked about earlier today and yesterday, you can always do an XY chart and then flip it. And then flip the X's and Y's, which is definitely highly suggestible in this case. And then they want you to find the inverse, which we've done about 200 times, I think, by now. At least that's what it feels like. So remember, always find your inverse from the completed square form. So from your answer in A is where you will find your inverse. All right, any questions?
No.
Nah.
You guys are going to hate chapter 3.
What is it?
Geometry.
Oh,
This is a joke.
Oh, they're pretty bad.
Oh, great.
Skip it.
No, some kind of freaking
You can't
book.
skip it.
All right.
Damn.
Yeah,
It's
nope.
joke.
You definitely need to do geometry. There's always at least one geometry question on there. So you'll
There
definitely want
proofs?
to. No proofs.
okay.
It's a
Oh,
geometry
fuck
question. It has shapes. Like it'll have a circle on there, a triangle, and sometimes they'll put them in each other. And I'm not gonna lie, it can be quite difficult problems, especially if you don't like. Unfortunately, if you don't like figure out how to do it, it seems like the most complicated problem you've ever seen. You're like, well, how the hell do I get this value that I need? But they're